This example is a really special case of a slant asymptote. Naturally, we see this a lot in upper-level mathematics. Just as we go along with it, if we factor this equation, you get x plus 6 over an x minus 4 on top, and you just have an x plus 6 on the bottom. So we notice right away we're going to have something that's going to cancel. Remember, do your domain analysis first, negative infinity to negative 6, and negative 6 to infinity. Now we can say, well, hey, that factor of negative 6 cancels. That means that's going to be a whole. There's no other time the denominator equals 0, so that means that we're going to have no vertical asymptote in this problem. So what's interesting here is that x plus 4 is all that you're left with. We know how to graph the line x plus 4, starting at 4 going up 1 over 1. So you'd have a graph, well, hopefully a little better than that, of going up 1 over 1. Same if I go in this direction. Something along those lines. Well, that's what our graph should basically look like. Let's see if we can get to it using our means that we know already in solving these equations and graphing these rationals. X-intercept is when numerator equals 0. Be careful. Don't use x equaling negative 6 because that doesn't exist anymore. Only when x equals positive 4 do we have an x-intercept. Y-intercept, plugging in 0, I get negative 24 over positive 6, so that equals negative 4. So if we want to take a look at this, if we plot those points at 4, 0 and 0, negative 4, does that really match the line that we just drew? Oh no, because the line wasn't x plus 4, it should have been x minus 4. So really that graph should be down like this, and hey look, it will match up basically to what we want it to be looking like. Okay, so that makes sense so far. Horizontal or slant asymptote deals with doing long division. We are going to get slant because the numerator is bigger than the denominator, and I'm going to claim that my slant asymptote is y equals x minus 4. Well, we can see that because really we're doing x minus 4 divided by 1. Well, that's an easy division to do. It's just x minus 4. If we had used our original equation, which is always more difficult to do, but it's certainly legal, and I give you permission, go ahead and try that right now, you'll get that your division answer is x minus 4. So what that means is we technically have a dotted line going right here. Now, to find where we cross our horizontal asymptote, we look at where the remainder is equal to 0. Well, check this out. We don't have a remainder. There's no fraction part over here. The remainder is 0. So when does the remainder equal 0? Well, it is 0. It always. So we're always crossing our horizontal asymptote. So that means our graph is actually just the horizontal asymptote itself. The only difference is this hole. At x equals negative 6, we need to have a hole here. So it would probably be best to get out the eraser here even and put that you have a hole. That's what your graph looks like. If you graph this on a calculator, as I bring the calculator in here, the original equation of x squared plus 2x minus 24 over x plus 6. What this should look like, when we graph it, it should just look like a line. There it is. Now your calculator is just doing a bunch of pixels, so you can't see where the hole necessarily is. However, if I try to type in negative 6, it doesn't give you a y value. And nor should it. If you plugged in negative 6, you get 0 in the denominator. You can't have that. But as I'm kind of moving along, I have y values the whole way following the line x minus 4, except for the fact that at that value of negative 6, all of a sudden we don't have anything happening. This is a really common problem, especially in upper-level math, calculus, where you have literally a line just with a missing piece in the middle of it.